Hello children, welcome to Scholars online classes. So in the last class we have seen few topics about matter, definition of matter, types of matter, and the properties of matter we have seen in the last class. And today in this class we are going to deal with a few 4 marks and very important questions in this chapter. Okay, so the first topic is today how the diffusion of matter takes place. In the last class we have seen what is the diffusion. Diffusion is nothing but the movement of air or vapor molecules from one place to another place is called as a diffusion. But today in this chapter we are going to deal with how this diffusion takes place, whether all the matter such as solids, liquids and gases diffuses or not. We'll see today. So the first one here, we'll see diffusion of liquids, diffusion of solids into liquids. We'll see. So to know this concept, we should have a small idea about the molecules arrangement in the matter. See, we have seen already in the solids that the molecules are situated very closely packed, in other words, okay, whereas in liquids there is a small gap between each and every molecule. Am I right? Yes, there is a gap. So here, to know this concept, how this diffusion takes place, we'll see through an activity, isn't it? So first thing, you take a 250 ml of a round bottomed flask which is available in your science laboratory, of course. So it is a 250 ml of round bottomed flask. Take some quantity of water, say 50 ml or 100 ml of water, and you take potassium permanganate which is available in your chemical laboratory in our school. So this potassium permanganate formula, it is KMNO4. Remember, potassium permanganate, KMNO4. Remember, the properties of the potassium permanganate is mainly it is a black colored shiny powder. Black colored shiny powder. So what are the, say now this potassium permanganate is available in solid state. Now take a pinchful with the help of a spatula, then slowly drop it in this water. Then immediately, dramatically, within no time, the potassium permanganate black colored powder, immediately it will be spreading all over this liquid, and immediately the color changes. Actually, with the help of red marker I have drawn here, but actually it turns to purple color. So now, what are the changes you have seen in this chapter, in this concept? So we will write the result. In other words, what you have observed here, the color change. Of course, here I have shown you with the help of a red color mark, but actually it is a black colored powder, isn't it? Of course, it won't change here. After touching the water, after it dissolves in the water, the color will change. Remember this concept, okay? Now what is happening here? What is the conclusion we will write from this activity? That is, see, this is a water, isn't it? Water is nothing but liquid. In this liquid there is a gap. What happens to this gap? When you drop or when you pour some spatula full of or a pinch of potassium permanganate, then the potassium permanganate comes and settles with this gap, isn't it? That means due to this, one liquid and another liquid, they collide with each other. That means the transfer of these molecules may take from one place to another place. Due to this reason, what is happening? The liquid molecules are moving and they are interacting with the potassium permanganate crystals or the powder, then immediately the color change. There develops a chemical reaction, you remember, isn't it? So from this activity, the conclusion is the solids diffuses into the liquids. Now, how this observing the diffusion of particles of solids into liquids, and how the gases diffuses into water. Example, aquatic life, aquatic animals, aquatic plants, all they are surviving just because of the diffusion property itself. How, sir? Just you think. See, the diffusion, according to the diffusion property, that means the movement of molecules from one place to another place itself. The oxygen molecules, what happens? It moves randomly and it dissolves in the water where the oxygen is available in the water after this diffusion. So due to this concept, due to this reason, the aquatic plants and animals, they are surviving in the water. That means they are getting, or they are obtaining the oxygen due to the phenomenon called diffusion, isn't it? Now let us see another important activity, and also it is very very important coming to your examination point of view. It comes for 4 marks. That is a simple lab activity. What is that lab activity? That means whether we have, air is a mixture of several gases, as you are learning from even 6th standard onwards. Now, do all these gases are having the same masses or the same speed, with the same speed, whether they are moving in this atmosphere? No. Somebody are saying, maybe you may be thinking like all gases will move same or all gases will not move same. But what is the correct answer? What is the diffusion rate of gases? That we will see through this activity. So from this activity, what are the materials you require? That is, first thing, a long glass rod of, assume that it is 1 meter, that is maybe 100 centimeters. So this long glass tube should be open-ended. Okay, 2 open ends. Now take 2 cotton plugs and you dip these cotton plugs in where 1 cotton plug should be dissolved in NH3 and another one should be dissolved in HCl. NH3 stands for, and the name of this NH3 is ammonia, and HCl stands for hydrogen chloride. Both these two are liquid and actually they evaporate. That means the gases evaporates. So ammonia gas and hydrogen chloride gas. Now according to the activity, what is our aim of this activity? To observe the speed of the diffusion of different gases. We are taking 2 gases. What are they? HCl and ammonia. Out of these 2, which moves very fast? That is what we are going to conclude from this activity. So what are the materials? Just now we have seen, that is 1 long glass tube and 2 cotton plugs and 2 gases. Now what is happening? After dipping these 2 cotton plugs in ammonia and hydrogen chloride gas and try to place these cotton plugs at the end of this tube. That means you are closing the tube's ends with the cotton plugs which were dipped in HCl and ammonia. Now observe what is going to be happen here. So what is going to happen? After certain time or few seconds, you can see there is you can see a circle. Okay, and this is, what is this circle? It is like a fumes. Okay, and the color of this fume is white and it is very dense. That means, what is the observation? White dense fumes, a ring like structure is forming in between of these two cotton plugs of white dense fumes. So we can say that by seeing this fume, we can say that it was a chemical reaction between of what? Ammonia and HCl. That means these two were mixed, but actually physically we did not. But what happened? The gas molecules of ammonia and HCl, they might have traveled through this glass tube. Correct? Did you understand now? The molecules of ammonia and HCl might have traveled inside the glass tube, and they met at somewhere else. But this white colored dense fume, where did it got? Or in other words, this fume or this ring like structure is nearer to which one? HCl or ammonia? How can we say this? See, for example, if you are participating in a running race competition in your school, if a hefty personality person is there, okay, as your friend is a little bit fat and your another friend is little bit thin, so for those two persons, if the running race competition is being done in your school sports, then who will come first? Your answer is right, exactly. The gas, the same way, the gas which is more denser than the first one or the second one, okay, that moves little bit slow. Now, how can we know that which gas? How we know these two gases? Out of these two gases, one gas is denser. How? How can we calculate? Is there any calculation? Or can we weigh with the spring balance or something else? Let us see. We have, according to the chemistry, of course, this topic and this concept you will learn in the coming classes. Just for understanding, I will give you a small calculation about this ammonia and HCl gas. Actually, the atomic weight or the molecular weight of HCl gas is 35.5. Remember, HCl gas atomic molecular weight is 35.5. How did it come? H plus Cl. Hydrogen's atomic weight is 1 and chlorine's atomic weight is 34.5. So that the I'm sorry, small clarity here, I'm sorry, very sorry. Hydrogen is 1 and chlorine is 35.5, so that the total molecular weight of this HCl is 36.5. Coming to ammonia, nitrogen is 14 and hydrogen is 1, but 3 hydrogens are there, hence it is 3, so that 70. Now you can easily identify the values. Which one is denser? Hydrogen chloride gas is more denser than this ammonia gas. Then immediately what happens? So this gas moves a little bit slower than ammonia gas. So these fumes, that means before it reaches to the other end, ammonia gas comes a little bit faster, so that the dense fume may form here nearer to this HCl gas. So if we measure the distances, easily we can come to know that the gases are diffusing with the different rates or with the different speeds. Did you get the clarity? See here, according to these two mathematical molecular weight values, ammonia moves with little bit faster than hydrogen chloride gas. So before this hydrogen chloride gas reaches to ammonia, the ammonia comes a bit faster and it reacts with the HCl, so that you will get a white dense fumes here. So if you measure the distance, so HCl gas and this white dense fumes distance is very less than this ammonia gas. So from this activity we can say that different gases have different diffusing speeds, isn't it? So what actually our aim of this activity? Observing or calculating the speeds of the diffusion of different gases. Is it okay? So today in this class you have seen two important topics. So how the diffusion takes place in solids, liquids and in gases, and the diffusion of different gases. Is it okay? Thank you, and we'll see the next topics in the next coming classes. Thank you very much, and you please practice all these activities, refer the textbooks. Possibly you practice this activity and practice the diagram, these two, because it comes in the examination for 4 marks. Is it okay? Thank you.